code on this computer. So let me give you a breakdown of the questions. Questions 1 through 4 are multiple choice questions where I give you a scenario and I'm asking you, of the 4 data structures I present to you, which is the best data structure to use? It's a multiple choice question. Okay. So, and this also brings one of my key kind of concepts that may not always come across in exams. All questions are essay questions, including multiple choice questions, in the sense that you can always justify your answer. Justifying your answer does allow you to possibly get additional credit, partial credit if you made the wrong choice, or if there's some. It's also possible I completely put in a possible right answer that you could work yourself to. It's happened before. I'm not infallible. So in those cases, what you want to do is, because you're just doing multiple choice, is like turn in some notes, which you can either do by hand. You can, email me your notes or whatever, or I'll add in another question where you can upload anything you need to, which is useful. So the first 4 questions are multiple choice questions, and they're fairly straightforward. I need a data structure that, for this scenario, which of these is the best one for this, which data structure models this the best. Questions 5, 6, 7, 8, 9 are all, I give you a single tree, but for all of those questions. That's just simply a tree with labels on it for each of the nodes, and I ask you to basically give me the vocabulary terms for each of the nodes, or not every one node, but like if, for instance, like the tree at the top, I say the tree at the top, node A is the blank of the tree, and you're supposed to put in root. Make sense? Right? And it's going to be the same tree for all the questions, and I'll just be asking you kind of generalized questions about that stuff for questions 5, 6, 7, 8, and 9. They are fairly low value points, but there's a number of them, which makes it add up, of course. Not too arduous. It's just to make sure, did you study the terms? I will warn you that you will probably get some initially marked wrong, and then I will send out a form and you can tell me which questions to double check. And the reason being is, again, it's just an auto grader. It's very possible to either misspell a word or possibly give me a British spelling I didn't know. So, I'm looking for exact matches. So, or like I'm expecting a number, but you typed out the number, right? I wanted 5 and you give me FIVE. And I don't account for that. And so those kind of things happen, right? So don't panic if it gets you wrong and you thought you were right, and you're pretty sure you're right. My grader is just simply there to really speed up the work of grading. Questions 10, 11. So let me see. Questions 10, 11, 12 are basically, give me traversals, adding and removing for this tree. So I give you a tree, please do a multiple choice selection of whatever the X order traversal is, or what is the following tree that happens when I add it. It's very similar to the ones I've done for the tree quizzes, right? So if you've done the tree quizzes, you know what to expect for those. Again, it's multiple choice so that you don't have to draw it out. Question 13 is a heap question, which is basically, here I'm giving you instructions on modifying the heap. Please give me the answer. Okay. So finally, those are all like non-coding questions. They're all conceptual. Shouldn't take you too much time. Questions 14, 15, and 16 are our coding questions. Questions 14 and 15 are linked together. They are basically the binary tree question. It's broken into 2 parts. You write a function and then you call that function in the other function. So you're writing 2 functions, and if you get the first one wrong, that doesn't preclude you from getting the second one, right? Yeah, I simply say you can use the name of method from the previous question and assume you wrote it correctly. So there. And then question 16 is a standard kind of the standard kind of question I ask on exams with maps, which is given a something, I want you to count the things in that thing. I want you to count, like, so for instance, like on the practice exam, I have given a string, please count, please give me a frequency count of all the letters of all the characters in that string, and tell me which the most common character is, which is difficult without a map. It's possible without a map, and certainly messy without a map. It becomes a lot more difficult if you're working in not ASCII though. So that's where the maps become really useful. And then finally, question 17 is a analysis question where I'm basically saying, here's the data structures we've been working with. Let's make a tweak to it. Now tell me, what changes did that tweak make, if any, to the runtime of our code? Okay, so overall students do much better on this exam when they study for it, because there's a lot of points there. Let me see. 45 of the points of the coding question, each of those coding questions are worth 15 points. And then the rest is just simply those multiple choice and the rest. So students tend to do a lot better if they've prepared for this, right? Because there's all that vocabulary and all the understanding the algorithms and understanding how that works. For the tree questions, make sure you understand how recursion works. Set up your base cases and your recursive cases. Make sense? Okay. All right. So again, that exam will be on not this week, but next week during your lab period, so you can have the full 2 hours and have access to a computer in front of you, right? They still have computers in the labs, right? So that'll be at so that'll be in your lab period on the 5th of November. The same restrictions apply for this as last time, which is that's open note, open book. And those notes encompass basically anything that you have on your computer, anything that's on your personal cloud, right? So if you prepared code in advance to copy, that's fine. But the greater web is kind of prohibited to you, right? No Stack Overflow.
And your Canvas page, right?
Yeah, and my Canvas page. But like, you can't, mind you, if you come in and you've already downloaded like a ton of Stack Overflow, I'll allow it because that's preparation on your part, right? So if you prepare, right, you bring in documentation, sure, that's fine. You can basically the amount you prepare, that's fine. The rule is you just can't access the greater web during the exam. Okay. And that's mainly to prohibit, both communication, but also so I can actually use the questions, and you can't just Google these questions because there's only so many tree questions I can ask that are interesting. There's only so many of them. Now, that being said, I can do a review session on either the 2nd or the 4th of the practice exam. So what would people prefer? I can do it either on the Tuesday or the day immediately before. So what are opinions on the matter? You said you'd rather have it on the 4th, so the day right before Tuesday. So do we want to vote on this? Okay, so hands up for Tuesday. Okay, and then hands up for Thursday. Okay, I think the Tuesdays have it, so I'm going to do, but regardless, I can still answer some questions on Thursday anyway. So the so meanwhile, what's going to happen after that? So what's after our second exam? sorting algorithms. We're going to go into good detail about sorting algorithms. Now, you've probably dealt with sorting algorithms before, I'm sure, or you probably had an introduction to bubble sort, insertion sort. I think Professor Fiore probably did, in theory, cover, like theoretically covered merge sort, right? Or quick sort or something, but not like go into depth about it, I'm sure. Regardless, I'm going to approach these sorting algorithms as though it's your very first time being introduced to these sorting algorithms. Make sense? Okay. Now, with regards to the sorting algorithms again, on our exams, we do like to, for the final exam, we do like to especially emphasize insertion sort, quick sort, and merge sort, because insertion sort is the most useful of the quadratic time sort functions, meaning the slower ones. It's the most useful of them because it has a lot of very interesting properties. And we like quick sort and merge sort because those are what we actually use for the most part. Yes.
When is merge sort better than quick sort and vice versa?
So quick sort is not guaranteed to all. Its worst case runtime is actually quadratic. It's not guaranteed to run in n log n time. N log n time being the best time you can get for sorting algorithms on a single thread. However, quick sort is space efficient, meaning it can be done in place. Merge sort cannot be done in place unless you're using linked lists, because merge sort requires you to chop up lists and break them apart and move individual items around. And doing it in place is an exercise left to the reader if you're trying to do it with an array. It's terrible. Yes.
Was quicksort the one that you like get the pivot and put it in the front and then like?
Yes.
Okay. I
Yes.
watched videos yesterday. I just want to clarify.
Quick sort is the one where we select the pivot, move and separate everything into everything lower than the pivot, everything higher than the pivot, and then recurse. You can do that. That's very easy to do theoretically using a linked list without having to worry about doing it in place. But if you're doing it on an array, it's a bit tricky, but you can do it in place. Once you know the trick, it's actually fairly straightforward. Merge sort. So Java does use quick sort, and it uses not merge sort, but Tim sort, which is a newer sorting algorithm that's a modification of merge sort. And it combines insertion sort and merge sort to kind of take advantage of the fact that most data you're sorting isn't actually truly random. Most data occurs in what are called runs, meaning that you have a group of ascending items and a group of descending items. So you have a lot of series of items. And so insert sorting into runs and then merging those runs together can make for a very more efficient runtime performance. Other sorting algorithms to note is the shell sort algorithm, which has an unknown runtime. We do not know what the lower bound on that is. It's still one of those unsolved problems, which is interesting. And finally, the other one which I will cover is radix sort, which has a runtime of WN, capital WN, where W is the word size. This is a unique sorting algorithm because it does not rely on doing any comparisons. You do not have to compare all the sorting algorithms. We measure the runtime based on comparisons, which is, how many times do we have to compare two items to each other to see if they're in order or not? Radix sort doesn't care about that. It just sorts without caring about any of that. And how does it do that? It does that with the magical power of queues, a lot of queues. I know that doesn't make any sense, but I'll go over it in class. It's a very, radix sort is a very unique algorithm. It's worth knowing about, and it's worth knowing why don't we use it? Well, because generally the runtime isn't as good unless we're dealing with billions of items. It's also important to note that since we are doing that, the general thing that we look at sorting algorithms for is the number of comparisons that I've just mentioned. But we also measure the number of exchanges, because that can matter. If you're sorting on a computer, comparisons is what matters, because you just swap memory locations around and copy data to do an exchange. That doesn't really cost anything too much. But if we are sorting, let's say, giant boulders in real life, then suddenly the exchange cost matters a whole lot. And so suddenly algorithms, which like selection sort, which have a n squared comparison no matter what happens, suddenly rush to the forefront because they have an O of n exchange. Every item gets moved precise. There's precisely n swaps of items, which is pretty nice. So it's worth noting that basically the context does matter. But the context is normally doing comparisons. All right. Yes.
So you would use radix sort if you have a bunch of numbers and only in that situation.
And also if you're building something that you want to do, you want to sort stuff mechanically without actually doing comparisons. That's what radix sort was initially intended for, like sorting cards, punch cards and the like. It could sort them without, because it would just simply throw them into the appropriate piles, and then you'd take your piles and it would merge them together. It's good for making machines that don't, for basically using if you want to make a machine that doesn't really have to do too much thinking. All right. And so the sorting is kind of a breather. Then we'll move on to graphs. Graphs are one of the more powerful data structures we have because a graph is all about relationships. It used to be that basically we had, graphs are a bit more abstract, and we had to say, and we would always talk about distances and stuff, like the distance from this place from this city to this city, and find the shortest path, or find the least expensive path of flights. But our world is now dominated by social networks, which is which is all about relationships, and graphs map those relationships, such as how many, the 6 degrees to Kevin Bacon, kind of thing, or the small world problem, which I'll give a small lecture on, which is, or small world phenomena, it's not a problem, that basically you can get from one person to another very quickly through just a connection of people. So, but graphs are really powerful because a lot of interesting problems can be mapped as relationships, and that term relationship is very broad. And then it will be time to practice for the final exam, and then you will have and then we will have our final exam. It'll be a common final. It will be in person, I would guess, because our lecture is in person. So, and as far as the common final, I write the common final. So, the question will be whether or not it's on paper, but I have to discuss that with my TAs, because I don't know if everybody has a laptop to bring to a final exam. So, it's just so much easier to grade on paper. Sorry, not on paper, online. So I will probably, what I might end up doing is just print out copies for people who prefer to take it on paper. All right. Any questions before we do demos? All right.